Yo, 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 Algebra 2, Miss H in the house. We are on final exam review, Mod 1. This is part 2, video 2. We're starting with number 12 and hopefully making through the rest of it. We'll see. As x goes to positive infinity for this graph here, where is f of x going to, is going to positive infinity as well. As f of x goes to negative infinity, wait, what? This graph doesn't go to negative infinity, so this does not happen. All right, what's our domain? Our domain for this guy is starting at -3, and the x values go on forever. So including -3 to infinity. For my y values, my lowest y value is here at -9, and it's going on and up forever. So from -9 to infinity. What's the maximum value? I don't have one. It continues on and up forever. I do have a minimum value. That's down at the bottom of this V shape here, which is at -9. Where is the graph increasing? So my graph is getting bigger. From 2 to infinity, the graph is getting bigger. So from 2 to infinity, don't include that 2. At 2, we're not getting bigger or smaller. That's where we're turning. It's a critical point. Our graph is decreasing from -3 to 2. That's where it's getting smaller. So when x is -3 to when x is 2, the y values are getting smaller. Where is this graph positive? Well, it's positive from, let's say, about 5.5 to infinity. The y values are positive. So 5.5, looks like a comma, 5.5 to infinity. All right, what are the zeros of this function? It's crossing right there at 5.5, so 5.5, 0. The average rate of change from -3, which is here, to 2, which is here. We're going down 1, 2, 3, 4, and over 1, 2, 3, 4, 5. So down 4 over 5. Same thing as finding, well, this one actually is a slope because that is a line. So find the slope of that line. That's the same thing as average rate of change. Down 4 over 5. All right, so this function continues as discrete. This is continuous. Again, I can draw this graph without ever picking up my pencil. All right. What is the value of f of 2? At when x is equal to 2, my y is equal to -9. It says when y is equal to 4, my x value is equal to 7. When is the function negative? So when are we beneath the x-axis? Sorry. That's going to be down here. So that's from x is equal to -3 to, we said, about 3.5. Sorry, positive 5.5. Graph f inverse on the graph above is f inverse of function. All right, so remember f inverse is where we take these points and we change the x and the y. So this point here is -3, -5. The inverse point would be -5, -3. So -5, -3 is going to be right here. That's the inverse point that corresponds to this one. This point here is at 2, -9. Its inverse point, we switch those guys, it's at -9, +2. And so let's put another one. So this one's 0, 5.5. So we've got another point here at 5.50. So this guy is looking kind of, look at it, like this. Kind of a cute little triangle thing going on there. Is that guy a function? No. The inverse is not a function because if I do a vertical line test, it hits more than once. So not a function. All right, number 13, a motorcycle is moving in a straight line on a road. The distance traveled by the bike at various times is shown in this table. The dependent variable of this relation is always going to be your x value. Your y value. Your y value depends on whatever your x value is. So the dependent variable, our y variable, is going to be our distance. The amount we've traveled depends on how long we've been traveling. So this is going to be distance. The maximum value then is going to be 270 feet. The minimum amount of distance we've gone is 0 feet. The relation is increasing over what interval? Well, it looks like it's increasing over the whole thing. So from 0 to 15. What's the average rate of change between 5 and 15? To find that, I'm going to look at this guy and find a slope between these two guys. So the change in y would be 270 minus 40. My change in x is 15 minus 5. So this is 230 divided by 10, which would be 23. And that's feet, change in y, feet over change in x, which is the second. What's the value of f of 5? So when quote unquote x is 5, my y value is 40. When y is 40, my x value is 5. Write an equation to express this relation. Well, we've got a slope here of 23. We know our y-intercept is 0, so f of x would just be 23 times x. All right. Find the inverse of the following functions. Then prove there are inverses using composite functions. All right, for number 14, remember we first start by writing this as a y. Step 2, switch your x's and your y's, and then you want to solve for y. So we're going to get rid of that 4 by multiplying it. 4x is equal to 2y minus 3. Again, trying to get y by itself, so I'm going to add 3. 4x plus 3 is equal to 2y. Dividing by 2, y is equal to 4 divided by 2 would be 2x plus 3 halves. So f inverse of x is 2x plus 3 halves. All right, to prove that's an inverse, I have to plug this back into my g of x for x and make sure it gives me 0. So 2 times 2x plus 3 halves minus 3 over 4. I think I actually simplified it too far, because I think if I leave this as a big fraction, it'll work better. Not that my answer was wrong, it's just sometimes we simplify too far and then we make the next step harder for ourselves. So let's just leave it like this. That way, when I plug it in here, it'll be a little bit easier for us. All right, so 2 times this inverse function minus 3 over 4. Well, 2 times this 2, they'll cancel out, and I get 4x plus 3 minus 3 divided by 4. 3 minus 3 is 0, so I get 4x divided by 4, and that will give me x, which is what I needed. So we've proved that this indeed is our inverse. All right, let's find it for h of x here. Again, start with y is equal to 2/3 x plus 5. Then we're going to switch our x and y, so x is equal to 2/3 y plus 5. Subtract the 5, I get x minus 5 is equal to 2/3 y. I'm going to multiply by the reciprocal there. And I get y, which I'm now going to call f inverse of x is equal to 3 halves x minus 5. Can I go ahead and distribute that out? Yes, but it's going to make it harder when I prove my inverse. So let's go to the proving the inverse. I'm going to plug this guy in for x here. So I got 2/3 times 3 halves times x minus 5 plus 5. Notice now the 2/3 times the 3 halves will cancel each other out. I get x minus 5 plus 5. Minus 5 plus 5 is 0, so this is x. And we've proven that I was correct. All right, let's see if we can't get one more done before the next video. 52. All right, how does f of x plus 2 differ from f of x? So this is a transformation question. The 2 outside of the parentheses in the back is a shift. It's a vertical shift. And since it's a vertical shift, it does exactly what it says it's going to do. It says +2, so it's going to go up 2 units. So the graph of f of x plus 2 is 2 units above the graph of f of x. All right, 17, the graph of the function f was obtained from the graph of the function g using transformations. Based on my graph, which equation can be used to describe f of x? So f was obtained from g. So we started with g. What did we have to do to g of x to get it to come over here? So let's just look at this point. We took this point and it shifted 1, 2, 3, 4, 5, 6 units to the left. So keep in mind, this is a hard one. First of all, we know it's 6 units, not 5 units. So it's not this one, and it's not 2 units. So we know it went 6 units to the left. But these are the tricky ones. It's a horizontal change that's going to do the opposite of what it says. So instead of writing -6, it's going to be +6 because we did the opposite, right? And then it went up 2. That's a vertical change. It does exactly what it says, so +2. All right, that is part 2 for module 1. Coming up, I will start with number 18 on part 3 video.